Welcome to Schweitzer Drive, a podcast where we explore what goes on between the generation of electricity and the light switch. Join Dave Whitehead as he interviews the entrepreneurs, innovators, and experts who are inventing the future of electric power.
Hi, welcome to Schweitzer Drive. I'm Nick Seeley, Senior Vice President of Engineering Services at Schweitzer Engineering Laboratories, and I'm filling in for Dave Whitehead today. And we're going to talk with Andrew Ginter about a new book that he has out on operational technology, cybersecurity. This is Andrew's third book on the subject, and it's called Engineering Grade OT Cybersecurity, A Manager's Guide. Andrew is Vice President of Industrial Security at Waterfall Security Solutions, where he leads a team responsible for industrial cybersecurity research, standards, and regulations. In the last 25 years, he's managed computer networking, product development, industrial control systems, and industrial cybersecurity for leading vendors like Hewlett-Packard, Agilent Technologies, and Industrial Defender. So, Andrew, hi, and thank you for joining us.
It's my pleasure. Thank you for having me.
All right. So wanted to start out just kind of asking some, introductory questions in terms of how you got into cybersecurity and what you do at Waterfall.
Sure thing. Let me start with how I got into it. I did, 10 or 15 years developing very technical software products. Sort of settled in the last half of that into industrial control system products. So I've developed parts of historians and HMIs and that sort of class of product. And then, sort of changed gears and built a product that connected industrial control systems to SAP, which was the thing to do in the mid 1990s. In the course of which, we wound up connecting a lot of IT and OT networks, contributing to the cybersecurity problems that now plague many industries. I got religion. I wound up at Industrial Defender. I wound up developing the world's first industrial SIEM. Turned out the world didn't want an industrial SIEM. They wanted an enterprise SIEM that could understand industrial. At least back then, this was a long time ago. The market has changed. Industrial Defender has changed. But now I'm at Waterfall. I lead a small team of subject matter experts. I work with, I have the privilege of working with the world's most secure industrial enterprises and, wrote a few books, in part because I observed that, the world's most secure enterprises didn't look at they I shouldn't use contractions. They don't come across. They do not look at the problem the same way that everyone else does. They ask different questions. They get different answers because they ask different questions. They look at the problem a different way. And so, part of what I'm doing writing is trying to capture that perspective and, try to add some value with my subject matter experts as well in terms of sharing the knowledge, sharing the wisdom, between the high end of cybersecurity customers.
I appreciate that. And you said something that actually just kind of made me smile a little bit. You said you got religion. And then something else you just mentioned that you were connecting industrial control systems to SAP, which I think just sent a collective shudder down the spines of a lot of people. Like there was just a disturbance in the force. Was there a particular experience that you had where you just kind of was like, wow, what are we doing? Or was it just a gradual over time experience and aggregation of experiences?
It was very gradual. I wish I could say I saw it all coming and this is why I wound up where I am. It's not true. I've described this process. Let me give you the next level of detail, but I'll be brief. I've described the process as intentional, but in all honesty, I was sitting in my cube writing code on, leading a team of, I eventually wound up being project manager on the industrial control system product. I was tapped on the shoulder, same business, saying, we'd like you to lead this other thing. I said, okay, and handed off the one task to a different manager and took on developing the middleware product, connecting to SAP. In the meantime, HP spun us off to Agilent, and then Agilent sold us off to Verano. Verano was doing supply chain stuff, was a startup. It imploded, ran out of runway. And the receivers looked around and said, there's still money coming in here. Where's this money coming from? It's coming from these other two products that that were obsoleted the day that Verano bought us. And they said, okay. So we basically did a reverse takeover. That, the technology we brought with us that was obsoleted was unobsoleted. And, we looked around for another opportunity, wound up signing Brian Ahern as a CEO. He took us into industrial control system cybersecurity. And so they tapped me on the shoulder and said, can you do that now? And I did. That was how I drifted into it. I wish I could say that I saw it all coming, but I didn't. Now, what I will say is going forward, the advice I give to young people is, look, for 30, going on 40 years, we have been automating everything in the business, in the industrial side, everywhere. All modern automation involves CPUs. For 40 years, we've been deploying more and more targets for cyber attacks. And data in motion is the lifeblood of modern automation. And every connection between computers is an opportunity to attack one computer from the other, to pivot and attack from one compromised machine to use it to attack another machine. And for 30, 40 years, we've been deploying more and more connections. Everything has become more connected. So we've been deploying not just more and more targets, but more and more opportunities to attack those targets. Are either of these macro trends going to reverse in the next 20 years? I don't think so. And so what I tell people is there's going to be ups and downs in the industry, but if you want, in a sense, a future-proof career, make a career of protecting computers, be they on the business side or on the OT side. That need is going to get much more intense before we come anywhere close to solving this problem.
Yeah, I love what you're talking about there, and I want to dive into more of that. But before we get there, I think it does maybe provide a nice segue. So you've had a lot of experience in this field, and that experience, it sounds like you are interested and willing to share that experience in the form of you've written some books. Can you talk a little bit about how you got started writing books, why, and then the books that you have written? And I think that'll lead us into your most recent book here.
Yeah. So where to begin? Let me start at the beginning. I'm approaching the end of my career. I see retirement coming sometime in the next decade, maybe much faster than that. Depends on how my body holds up, how my health goes. What I will say is to young people entering the field, when I was going through school, I loved math. I loved physics. I hated English. Get over it. Learn how to write, people. The more senior you become, the more you're called upon to write. Everything from requirements documents to user manuals to me, they were one and the same. The way I specified how the SEM had to work was to write a draft user manual saying, these are the screens. This is what the data looks like. You figure it out. And the dev team went, I can do this. And off they went. So, and, as a leader, eventually you're expected to start writing for the public, for magazines, for, presentations, and eventually the book. So, if you want to advance in your career, I suggest you need to look forward to more and more writing. Start getting your fingers dirty. Ask if you can contribute to a blog. Start taking first steps. This is, it's a valuable skill. And in terms of the books, I've always wanted to write a book. I wanted to believe that I knew enough that people would read my writing. It was a very selfish goal. Getting focused was really hard. I took several runs at my first book and threw them out because I lost focus on who my audience was. And now I don't know if this is a thing with just me or with everybody, but if you lose track of your audience, the only way I got these books written was when I could finally picture a person. I can see your face on the screen. I pictured a person that I knew 3 years ago. I knew what they knew 3 years ago. I knew what they needed to learn over the next 3 years. And I could write that down for them. Because then If you don't have that picture, you don't know what to write. You don't know what your audience knows already, because there's no point teaching them something they know already. You don't know what they don't know already. It goes all to murk, and you don't know what you got. So that was my insight with the first book. It finally crystallized when I read an article in IEEE Spectrum, the high end of, not peer reviewed technical writing, that was just wrong. It was a description of what happened in the first attack from Russia on the Ukraine and the cyber. They just drew entirely the wrong conclusion. And I'm going, how can this be? Who is this person? As a staff author, where did they get the information from? They quoted a bunch of people selling product into that space. And of course, so they recommended their own product, saying that's what would have saved the day. I'm going, no, that wouldn't have saved the day. And so I threw out the current version of the Red Book, and I determined to sit down and write the shortest work that a staff author like this person, who I didn't know, but I kind of knew what they knew, so that this person, if they'd read the book, could never write an article that was this wrong ever again. Because I thought, what else can I do? What am I going to do? Send a strongly worded letter to the editor? I mean, who's going to read that? This is IEEE Spectrum. People are going to be quoting this article for the next 20 years. And so that was the genesis of the Red Book.
I agree with you about the writing. I mean, even just emails, internal emails, being able to express yourself, with clean, clear, concise, coherent ideas is important. And then one of the best pieces of advice that I was ever given, I think is similar to what you're given, is write papers and present them. Like, become known in the industry within which you would like to become a part of. So yeah, heartily agree with you there. Kind of fast forwarding to the latest book that you have, I really thought it was quite big of you to start out in the prologue with some very critical feedback that you had received on previous books. And there's I'm sure it's in every industry, but in cybersecurity, there's no shortage of people that have some very critical feedback. But I like how you brought it out and you just kind of laid it on the surface and said, here's the feedback that I've gotten. And then I mean, you didn't try to necessarily retort, right? I mean, you didn't try to say, no, this is why they're wrong. You just you went with it and kind of explained it. Can you share a little bit about that
Sure.
experience, and then just kind of how that helped inform this book that you've written?
Sure. So, the first book, I got feedback from, industry recognized experts. It ranged from, Andrew, I disagree so fundamentally with your premise that I could not finish reading this thing, all the way to the other extreme. It was the chief security officer of a medium-sized power company. And, I asked her for feedback on the book. And, I kid you not, she looks at the floor and she looks up at me, and I'm going, oh, this is going to be bad. And she says, Andrew, it must have taken weeks of your life to write this thing, yet everything you've documented is obvious. What would possess you to spend so much effort documenting the self-evident? So all the way, from so disagree so fundamentally I couldn't finish reading it, to so obviously true it wasn't worth writing down, and everything in between. And so it taught me two things. One is experts disagree, so get used to it. And the second is nobody likes a critic, because the title of the first book says it all. SCADA Security, What's Broken and How to Fix It. What's broken? I criticized a widely used approach to industrial cybersecurity. And of course, the people who were promoting and practicing that approach were offended. I thought I could show people the light and they would follow me to the light. No. When you criticize someone, they get their shovels out and they start digging that hole deeper. No progress. So I don't recommend the Red Book anymore. Another piece of feedback I got in the Red Book was that people really never made it. Most readers never made it past chapter 2. And I took the wrong lesson out of that for my second book. I said, oh, then I'd better get everything into the first 2 chapters. And chapter 2 was really quite complicated in my second book. But that wasn't really the lesson. The lesson was that chapters 2 and to a degree chapter 3 were introductory. I explained for someone who wasn't familiar with industrial control systems or OT systems, what they were and how they worked and why they were a little bit different. And I explained to people who weren't familiar with cybersecurity how attacks worked and, why, what you have to understand who's coming after you. You've got to understand roughly what they're going to do to you before you can design anything like an effective defense. And so that was the lesson I tried to apply in the new book, which is write all of it in the high and slow fashion of chapter 2, because that seemed to be what people were looking to read. Now, some of the feedback I've got, very preliminary, a lot of people haven't read the book yet on the third book, is, the experts have said it's kind of pedestrian. I'm going, yes, that was by design. But, other less expert people have said, I'm a little bit into it and I'm tracking. So this is good.
And the book is titled, right, Engineering Grade OT Cybersecurity, A Manager's Guide. And so from that title, I'm figuring that this is directed, right at managers, right? So it's you're not going super technically deep, but you're also explaining things at a level that you feel managers need to understand, right?
That's right. And the punchline in the new book is chapters 7 and 8, which tries to answer the question, how much is enough? What is the right amount of security? And the answer turns out to be a little bit surprising. Let me back up a second. A lot of people use the IEC 62443 standards, very detailed, 14 volumes. Only 8 of them have been written. The other ones are still under development. And what people don't realize of those standards, and of pretty much of most of the cybersecurity standards out there, things like NERC-CIP are a little bit different, but they don't realize that they're written every bit as much for a small shoe factory as they are for a high-speed rail switching system. In terms of consequences, 2 very different animals. In terms of the required security system, very different animals. And people look at them and say, well, I need to be 62443 compliant for my rail switching system. So let me look at the standard. It says, well, the minimum you have to do is this. Okay, so I'm going to do that. So I've done the minimum. There, that's step 1. I'm minimally compliant. I've got 62443 behind me. Now I can look at better stuff. The minimally compliant regime is for a small shoe factory. It's not for a passenger rail switching system. And people don't realize this. And so this is kind of what I tried to highlight in chapters 7 and 8, how to make an intelligent decision, a reasonable decision about how much security do I need in my system. And one of the key concepts is, what is the worst that can happen if a cyber attack comes in? And is that worst an acceptable consequence? What's the worst in a shoe factory? I have to shut down for 10 days. I have to restore from backups. I lay my people off. They're annoyed with me. Then I pay them overtime to make up lost production. Now the people are happier with me. It cost me $10 million. I buy insurance for that. Is that an acceptable consequence? Yeah. It didn't drive me out of business. It annoyed a few people and, I'm good with that. What's the worst that can happen on a high-speed passenger rail switching system? We, seconds after compromise, have a collision, mass casualty event. Completely unacceptable. So that's, one of the key concepts is answer that question, and that will determine the rest of your security program.
Yeah, I appreciate that, right? Because we look as SEL, we are, we have certification to 62443-4-1, right, which is secure product development, and part of the reason that we like that is because it's not very prescriptive, right? It allows us to define what we feel is our appropriate controls, and I think where you're coming from is yeah, that's fine, right? But you have to be honest, you have to be forthright with what actually is a required level of control, and 62443 is not gonna tell us that.
Yeah, the example I use is not so much in 4-1. I'm more familiar with 3-3, which is the
systems
security controls for systems. Mm-hmm. And the security levels are described in terms of the capabilities of the adversary. Right. They don't use the term, but I would say SL1 is roughly script kiddie level. Mm-hmm. SL4 is nation state. SL3 is, let's call it organized crime. Mm-hmm. A lot of people look at it and say, nation state, I'm just a small water treatment plant. I have 1,000 subscribers. Why would a nation state come after me? And what they don't realize is that today's criminal groups, ransomware, some of them are nation state backed. Some of them are rich enough to buy nation state grade tools. The pervasive threat out there, some of the ransomware groups are nation state grade, and they come after everybody with money. Do you have money? Yeah. Then you're going to be a nation state grade attack target. Oh, and so the question becomes, is that, is the worst case acceptable? If the worst case is acceptable, buy some insurance. Doesn't matter if it's nation state or somebody else coming after you. If it's acceptable, it's acceptable. If it's not, now we've got to look at who's coming after us. And most people, they say the words, why would a nation state come after me? Not realizing that it's ransomware.
Along the subject of kind of attacks, ransomware, one of the things that we've seen, and I think, you correct me if I'm wrong, but I seem to suspect that ransomware is going to be the most likely type of attack that most organizations see. And that tends to go after the IT system, I seem to assume, and based on kind of my experience and what I know, is that's going to be more easily done on IT systems, right? And you make a very interesting point that attacks on IT, there are people that would say that attack on the IT system is not necessarily an attack on the OT system. And I think you have a portion of your book, or a sentence in your book, that kind of disagrees with that notion and kind of uses the Colonial Pipeline as an example of, yeah, that was an attack on an IT system, but it did bring the OT system down. And can you kind of elaborate your thought process on the differentiation of attack on IT being an attack on OT?
So, let me do a bit of a plug here. If you're interested in more detail, it's all in the Waterfall 2023 threat report, and the 2024 is coming out. But what we report on, what we count in that threat report, all of the cyber attacks since 2010 that met our criteria. The criteria are deliberate attack, not errors and omissions, not equipment failure, deliberate attack with physical consequences, not near misses, not information stealing, deliberate attack with physical consequences in heavy industry and manufacturing, sort of the industries we understand. I'd love to do something on healthcare, but bluntly, I don't understand it. I don't practice in that space. In the public record. So in a sense, this is the most conservative report out there. Everything we count, we provide a link to. You can go to the front page of the New York Times and decide for yourself if it's worth the criteria. The feedback I've had is, Andrew, most of these are IT incidents, not OT incidents. And I'm going, that's what do you call it? Splitting hairs. The IT and OT teams might stare at pick Colonial. The bad guys came into the IT network and OT was shut down out of an abundance of caution. The IT and OT teams might stare at each other and go, well, you don't, well, you didn't, it was your problem. The business doesn't care if it was an IT incident or an OT incident. They care that the pipeline shut down. And when the pipeline shuts down, they're going to take the IT heads and the OT heads and knock them together until this problem is solved. And so that's why we use the criteria we do, which is we're counting. Basically, we're trying to assess cyber threats to physical operations, no matter what the path to the physical outages is. And, once you start looking at it that way, something that people have been talking about in the last 2-3 years that I've never heard them talk about before is interdependencies. It does no good to have the world's strongest OT security system. Nothing gets in, absolutely bulletproof, if physical operations depends upon servers on the IT network that have been crippled by ransomware. The textbook example is not even Colonial. The textbook example is, I have a manufacturing facility that produces, a pallet of Coca-Cola. I mean no harm, Coca-Cola. I shouldn't name a brand name here, but pop, a pallet of pop once every 3 seconds. Bang. Next. Bang. Next. These are high-speed production lines. And the printer that prints the label on each pallet is on the IT network. IT goes down with ransomware. The printer stops. The factory could keep going. We've got production orders from SAP backed up for 10, 12 days here, but we can't print labels anymore. And if we take pallets of POP into our warehouse or our system of 24 warehouses without a label, we'll never find it again. And so these interdependencies, these relationships between IT and OT networks are important. And need to be explored and really haven't been explored beyond the last couple of years.
Yeah, I think especially during COVID, at least for us, like the whole supply chain. We track supply chain quite a bit here at SEL just because we want to know where we get our parts. We want to know that we can get parts. And all of that is dependent on a lot of IT systems, right? So there is a very strong correlation between IT and OT, as much as we sometimes don't want to acknowledge it. So getting into kind of the meat of your book, your latest book, you talk about engineering grade solutions, and engineering approaches to cybersecurity. So can you talk a little bit more about that? And then I've got a kind of a follow-up question that I would like to get your opinion on.
Go for it. So, engineering grade. So let's talk about the difference between an engineering grade mitigation for a certain threat versus, and let's call it IT grade. IT grade is what we've been doing for 20 years. We've been longer passwords, intrusion detection, antivirus, host hardening, and so on, patching, the big fish in the room. Engineering grade, if your life depends on a boiler not blowing up in your face because a cyber attack overheats the furnace under a 6-story boiler. Would you prefer, what protection would you prefer from that cyber attack? Would you prefer a mechanical overpressure relief valve where, if the pressure in the boiler becomes too great, it forces a piece of metal against a spring, the steam escapes, the valve opens, and there's no explosion? Or would you prefer a longer password on the PLC controlling the boiler, controlling the furnace? Most people say, I'd like the valve, thank you, because it's unhackable. In a sense, the correct answer is, Andrew, that's the wrong question. You've asked me the wrong question. I want the valve. I want 3 of them because these things are mechanical. They do wear out. They rust sometimes. And I want the password. And I want a boatload of IT-grade cybersecurity beside it because this is my life on the line. Thank you. And they're right. The new Cyber-Informed Engineering Initiative, which I'm a great believer in, out of Idaho National Labs, U.S. Department of Energy is funding it, positions, cyber-informed engineering as a coin, addressing cyber threats to physical operations, positions it as a coin with 2 sides. One side is cybersecurity. Teach engineering groups about risk, about cybersecurity. Been singing that song for 20 years. Nothing new there. The other side of the coin is engineering. Use these overpressure relief valves and, centrifugal governors and breakaway clutches. Use these, in a sense, mechanical, analog safeties to address not just the risk of an earthquake crimping the outlet valve on the boiler and causing the boiler to explode, to address, not just the usual physical threats, but to also address cyber threats. And I've seen people do that. They're using these engineering tools to address cyber threats, but it's not being done universally. It's not being done systematically. It's being done sporadically by individual practitioners who are more on the ball than average. And so that's sort of, I define engineering grade as deterministic, as, a system whose failure modes can be modeled reliably mathematically. Think bathtub curve for physical failures. What's the opposite? Imagine, what's IT grade? Imagine that the engineering profession has figured out how to build bridges at 1/3 of today's cost for suspension bridges. Think carbon fiber instead of steel girders or something like this. The problem with the new design is that it's absolutely riddled with harmonic frequencies. You remember, we all remember dimly, the Tacoma Narrows disaster, one of the world's first large suspension bridges. A stiff breeze came up, started oscillating, and tore itself to pieces. To deal with these harmonic frequencies, the profession has designed active vibration dampers into the bridge. The bridge feels rock solid when we use it because all of these frequencies, all these bits of vibration have been actively dampened with, quadruply redundant power supplies and triply redundant software systems and so on. How happy would you be driving across that bridge if you knew that the design engineer for the bridge hoped that if a cyber attack targeted the AI controlling the dampers, hoped that we could detect the attack before it crippled the dampers? How happy would you be driving across that bridge if you knew that the design engineer hoped that if we detected it, that we could scramble an incident response team fast enough to prevent compromise of the AI? Hope is not what we expect of the engineering profession. We expect deterministic, reliable solutions. We expect a bridge to hold a specified load for a specified number of decades in a specified operating environment, with a large margin for error. I mean, I talked to an engineer who designs bridges, pedestrian bridges, like one close to where I live. I said, how do you model this? It comes out of a football stadium into a residential area. When the football stadium lets out, it's wall to wall people coming across that wide pedestrian bridge. I said, how do you design that bridge? How do you figure out the maximum load? He says, well, Andrew, it's easy. There's barriers on either side. People are mostly water. Most people are less than 2 meters tall. Model 2 meters of water, the width of the bridge, the length of the bridge. That's your maximum load, he says. And then he says, you multiply it by 8. And that's what you design the bridge for, because these are people. Failure under load is unacceptable. We expect that when there are unacceptable consequences, when there's threats to public safety or national security, we expect people designing automation systems to design them to hold a specified threat load for at least as long as until our next opportunity to upgrade, because these things come at long intervals with a large margin for error. That's what the public expects of us. This is what I'm documenting in chapters 7 and 8. Here's my theory right now. I'm still working on it, but it's my theory is that, and I think the term cyber informed engineering kind of has a nod to this. They don't call it cyber engineering, right? They call it cyber informed engineering. My thought on that is, if you call something engineering, that presupposes that there is a scientific foundation upon which that engineering is built upon. Cybersecurity, we don't have that, right? We don't have these sound scientific fundamentals. We haven't discovered them. We haven't formulated them. So at that, we have to, instead of have cyber engineering, we have cyber informed engineering, where we understand cyber consequences, and then that helps us inform the engineering that we can actually do, like the physics-based engineering that we're all capable of and have done for, since Newton kind of formalized mechanics and whatever the 1600s or whenever he was around. Is that I know I'm just springing that on you, but do you have a thought on that? Does that sound notionally true, or just? I'm not sure I tracked your concept there, but yeah, I accept the point that, or I argue that we need engineering grade solutions when public safety is at risk. What I also point out, but given recent interactions about the book, perhaps not as clearly as I need to, I try to point out that there aren't engineering grade solutions for all possible cyber threats. And so, given that there aren't those solutions for some cyber threats, what is reasonable to do? I argue, and you can argue with me, but I argue that when engineering grade solutions exist, we should probably use all of them that are applicable, because public safety is at risk. People say national security. How would national security be at risk? Well, what happens when the overpressure valve engages? The steam comes out, there's no explosion, and we shut the power plant down, because that's never supposed to happen. Okay, that's a safety incident. We shut the power plant down until we understand what just happened there, and we change the system so it never happens again. Why is that a problem? It's because any large power plant is critical infrastructure. Critical to what? Critical to the nation. That's the legal definition of critical. It's critical to national security. Oh, so When I say national security, we're talking critical infrastructure. Yes. And so when we have threats to public safety or threats to the nation, I believe we have, I argue that we have an obligation to use all of the tools at our disposal, everything reasonable, everything practical. And, these engineering grade tools have been used for almost half a century now. They're reasonable, they're practical, they're affordable. Everyone uses them. Use them to address cyber threats where you can. And the rest of the time, we have to do what we can. We put really strong IT grade security in place. Every layer of it we can layer in there, and wish we had something stronger. And so, this is where I see opportunities. If the marketplace can start saying, I want engineering grade solutions for situations where the consequences are unacceptable. If the demand is there, innovators like yourselves will respond to the demand. And so what I'm trying to do here is create a demand, not just among the engineering community, not just among the cybersecurity community, to a degree among the public at large, a demand for engineering grade protection for public safety, so that the world's innovators can say, well, we currently don't have an engineering grade protection for, people getting tricked into carrying USBs into the site. Let's create one, because no one's going to buy it unless there's a demand for it. So I'm not sure I answered your question, but I see the lack of engineering grade protection for certain kinds of threats as an opportunity to create new solutions in the marketplace.
Part of the work that we do at SCL is do these solutions, right? So we do services work where we go in and we harden substations like networks, harden networks. We look at what the control system is, and then we provide those solutions. So I'm a little bit, I think I'm a little bit somewhat at a loss of, I understand what we do, but I like that's our world. So you come at it from a little bit different perspective, where I think you've seen a lot of stuff that maybe we don't see in work with people that do things maybe differently than the way that we would do them. And it seems to me that those occurrences for you are kind of what are making you a little bit nervous in thinking that there's a requirement to re-envision like these engineering grade IT, OT, cybersecurity solutions. Do you think that's reasonable, like a reasonable assessment?
Yes. And so let me one of the points I make in chapter 8, we've talked about IEC 62443, SL1 is script kiddies, SL4 is nation state. The standard says when you separate your network into zones, you have to assign one of these levels to every zone. And what I point out is that we really need a different way, a subtler way, a more finely distinctive way of dealing with cyber risk, cyber threats. I've argued that the pervasive threat on the network is ransomware. How do modern ransomware groups work? They pivot. They take something over, some, insignificant computer. They use it to attack other computers, to steal credentials. They use those compromised computers to attack even more valuable targets. And basically, if you can set up TCP connections between your computers, then in theory, at least, you can pivot through your network to the most valuable targets that are reachable by that pivoting path. And so because it's nation state grade ransomware coming after us, I argue that the entire pivoting path is exposed to the internet. Doesn't matter how many firewalls are in between, if you can pivot through them. And so what we need is we need engineering grade protection across the board from nation state grade attacks coming through the network when the consequences are unacceptable. But if you have, let's say you've got an old school air gap going, and you've got, 50 computers that simply cannot be reached by a pivoting attack from the internet. It might be air gapped. It might be, waterfalls unidirectional, but you can't get in there. Does that mean you need no security in there? No, you still need security in there because, of the USB scenario, because of malicious insiders, who knows? But now the question becomes, well, you needed SL4 grade protection from network attacks. What do you need from non-network attacks or from internal network attacks as opposed to external? You have to look at your threat. Is it, the example, a small water treatment utility, 1,000 subscribers. Is it reasonable that an enemy nation is going to put a sleeper team of 3 terrorists, a sleeper cell, into your workforce in that small 1,000 subscriber water system and trigger them in 20 years and, take you out? That's just not a reasonable threat. Okay. The threat from insiders is different from the network threat. And so, do we need engineering grade protection against a sleeper cell? Well, that's not a credible threat. And so, well, A, no such engineering grade protection exists, but B, maybe it's not such a bad thing because it's not a credible threat. Now, if we're talking the high-speed rail switching system, if we're talking a nuclear generator, I'm sorry, it's suddenly a credible threat. And we don't have engineering grade protection. So, we see the nukes gluing their USB ports shut. We need a sort of a subtler distinction of who's coming at us and where do we need engineering grade for what kinds of threats is a little more complicated than the sweeping blanket. We need SL4 everywhere. It's not true. But it is also true that I believe we need more engineering grade protection than we have. And so part of my job here is trying to raise awareness for that need so that the end users start demanding it. And, innovators in the space have an opportunity to create solutions.
Yeah. Would it be fair for me to kind of rephrase some of the things that I heard in terms of, yes, in certain cases, engineering grade protections do exist, but maybe not as broadly as we would need them. And there are other areas where maybe there's a gap that we need to be filling. Do you think
Absolutely.
That's accurate? Okay.
Yep.
So I guess one last thing, I think we'll wrap up here, but I do want to, a lot of times cybersecurity conversations are a lot about doom and gloom. And that tends to be my kind of MO, is like disposition of like, I'm always thinking about the worst possible scenario and how something could go wrong. But I'm hoping we could end on maybe a little bit lighter note. What do you think is going right in the industry? What do you think has promise and helps you sleep at night?
I am very encouraged by, but we've been talking about it already, the Cyber Informed Engineering Initiative. I have, had opportunity to provide basically briefings on much of what we've covered here, which is, the threat environment, the exponential growth we're seeing. People look at that and go, it's not good. And then I explain what CIE is and the possibility of engineering grade protections for at least safety systems and possibly other kinds of systems, network engineering. They look at that and they go, that actually makes sense. That's it's not universal. I've had people still push back, but 2 years ago, when the only message I had was, the bad guys are clever. We need cybersecurity. What's cyber? Here's the analogy I use is, look, historically, engineering teams would go to the local cybersecurity experts, the enterprise security team, hat in hand, take their hat off, hold it in their hands and say, please, sir, can I have some cybersecurity? And the teams would drop some cybersecurity in the hat. And the engineers would look at it a little sideways and go, oh, that's horrible. We can't do that. And it just didn't work. They had to do some of it, but it was just hard. And the reaction I'm getting increasingly, not universally, but increasingly, let's call it the majority consensus, having presented this material, is this actually makes sense. It's the same puzzle pieces, but we've arranged them differently and they fit. And so, where people used to be, by analogy, sitting on their hands saying, I don't know. This stuff is hard. It doesn't seem to be terribly effective. It's not solving the problem. Now they're taking their hands out and they're saying, here's my checkbook. I understand the problem. I understand the solution. This is the right way forward. And they're taking steps. So I'm very encouraged by CIE because it's fitting the pieces together in a different way, a way that seems to make sense to the people I'm targeting in my book, to the business decision makers who have to say that does make sense. We have an obligation to do this. We have to protect the public. How we protect the public makes sense. You've asked for money. Here's the money. Make it happen. And so to me, I'm very encouraged by what I see there.
All right. Progress. Andrew, thank you very much. This has been a great conversation. And before we close, I want to mention that you are a co-host of the Industrial Security Podcast, which you can find on Waterfall's website or Apple's podcast. So for any of our listeners, please check that out. And just want to say again, Andrew, thank you for joining us. Great conversation.
Thank you so much. And I will add one more thing, and that is anyone wants a copy of the book, you can get it on Amazon, but you might just want to go to the Waterfall website, waterfall-security.com/engineering-grade-OT-security. You can request a copy in celebration of the launch of the book. It's not a book about Waterfall. It's a book about security, but in celebration of the launch, Waterfall is making free copies available to practitioners. So, ask for a copy. We ship to most of the world, but not all of it. So you'll see on the site.
All right. Appreciate that. Thank you, Andrew.
Thank you so much.
Thank you for stopping by Schweitzer Drive. Join us again as we learn about, explore, and celebrate electric power. For more information about the show, please visit selinc.com/Schweitzer Drive.